No way. No way. We'll just skip the break later, that's all.
Take the break now.
All right. Let me open your Excel document for you.
Oh, right.
Mike. Okay, you tell me when to pull that in. We're going to go ahead and go with that microphone, okay?
Okay.
Thank you.
All right. My name's Ben Markle, and I am on the SLS Space Launch System IV&V team here. My presentation is on using XSLT to transform the output of more than one static analysis tool into a consistent spreadsheet format. That sounds like a mouthful, but it's actually a fairly simple process. The scope of this presentation is fairly limited. So in abstract terms, what I'm describing is a way to collect data from multiple different sources and collect it into a single place, filter out information that we're not really interested in, reformat data that might be a little different between the sources, and then that basically allows us to work more efficiently and quickly. When I refer to tools during this presentation, I'm pretty much always referring to the commercial static analysis tools. What I'm presenting here is more of a process or a method of converting the data that the tools output rather than a tool that does this. So the only thing I actually wrote was a XSLT style sheet, which I'll talk about a little later, which is kind of like a conversion template to turn data from one form into another. So XML and XSLT, I'll get to the definitions later, but they're basically open standards produced by the World Wide Web Consortium, and they're used in internet technology a lot to pull data out of databases and display it on web pages. So the example we'll get to use NASA's Core Flight Executive software, which is open source software developed by NASA. And so I didn't actually use any IV&V project software in the presentation. Okay, so the agenda. So there's basically three main sections with some notes specific to one of the static analysis tools, Clockwork, at the end. We'll have some examples of what the data looks like after the second section. And the third section is sort of nuts and bolts description of using this process. So if we don't have time, we don't necessarily have to go through it in detail. So let's see. Okay, so I guess before we get too far in, just if you're not familiar with static code analysis, I'll give you a really quick overview. It's basically you run proprietary commercial tools against source code, and these tools will identify potential problems based on configurable checkers. So it's kind of like a standards checker, but it checks a lot more in-depth things than just coding standards. After you generate the results, you tend to need to filter out some of the data because they produce a lot of data. So if you have low severity issues or issues that come up against code that's out of scope of what you're doing analysis on, sometimes the tools have false positives, so you want to filter that kind of stuff out. So static analysis is useful for IV&V because it provides objective evidence about the quality of your code. It enables you to run automated tools on large amounts of software. Let's see, what else? So on the next slide, I'm going to talk about why it's useful to export the results from these commercial tools into a spreadsheet. And it's also useful, which I'll talk about on the slide after next, why you might want to run more than one static analysis tool. Okay. So, when I first started here, I was kind of curious why a lot of people who run static analysis tools export the data to a spreadsheet to go through the results. Turns out there are actually several pretty good reasons for that. One is to conserve the use of limited licenses. Sometimes we have situations where more people want to use the analysis tool than we have licenses available, so some people have to wait. So if you export the data offline, you don't have to use up a license while you're going through your results. So you can also analyze the data offline. There are cases where access to the code is restricted and you have to go onto the vendor's site to look at it, but then you can take the results back with you and go through the results offline. And the interfaces that the commercial tools provide have some limitations, so that you might want to keep track of information about the results that the commercial tool doesn't let you give. So those are some reasons. And another reason, which isn't on my chart here, sometimes it's nice to store the objective evidence separate from the vendor-specific tools database, just so we can control our evidence. Okay, so reasons for running more than one static analysis tool is basically that each tool has unique checkers that the other ones don't have. So combining multiple tools gives you a higher level of assurance on the goodness of the code, gives you a broader coverage of checkers. And it also allows us to evaluate the tools against one another so we can kind of keep track of things like where one tool might identify a bug and another tool might miss it. And that way we can gradually kind of keep notes about whether some tools are more effective for certain kinds of errors. So it sort of functions as a way of peer reviewing the tools in addition to just giving you broader coverage. Okay, so you run into problems when you're sometimes importing static analysis data into a spreadsheet. Basically, XML data can have records nested within records within records, and Excel is obviously two-dimensional, just rows and columns, and there's something called flattening that can occur. And basically, Excel, when you import XML data, tries to figure out the best it can whether what to put in rows and what to put in columns. And so I have an example of flattening. So can we look at the spreadsheet. Okay, so what we have up here is a really simplified XML file, just in a single cell in Excel. And this is kind of an example I just cobbled together to show what I'm talking about with respect to flattening. So if you look at these top two things in bold, there's a description and a field called number of errors. Well, when you export this file into Excel, it looks like this. And as you can see, these first two columns that were only in the XML data once are now in every single row. And so that can kind of pose a problem if you have hundreds and hundreds of records, because you end up with some duplicate information. Okay, can we go back to the other thing now? I'll only do this one. Oh, yeah, I can do it. Oops. There we go. Okay, great. Okay, so next slide. All right, so another problem dealing with importing multiple tool output into a single destination is that the different static analysis tools don't have the exact same information. So this is a little chart that I put together as I was coming up with this process. The first column has the fields that Clockwork Insight, one of our tools that we use, has available in the output. The other column that has blue in it is the information that CodeSonar outputs. And so some of these have basically equivalent information, but the tools call it by a different name. So when you put it into the spreadsheet, the column title will be different. So examples are the first one. Clockwork calls its unique ID for a finding a problem ID. CodeCenter just calls it an ID. Clockwork identifies the source path of the file as something called file path with no underscore and a capital P. CodeSonar puts an underscore between the two words, and it's all lowercase. And actually, the output also, if you run this on a Windows system, the capitalization of the path and file name is different. Basically, on Unix machines, paths and file names are case sensitive, but on Windows machines, they're not. And one of the tools just automatically makes everything lowercase. So when you try to look at your destination data and sort it by the file name, they won't come up in the right order. So the process that I'm demonstrating has a way to get around that. And anyway, so there are a few other differences between fields. Another thing this chart shows is the ones in blue are information that I decided to keep. Some of the information that the tools output are duplicates of other fields, so it's not really necessary to keep all of this information in the same file. And some of it's just stuff we're not really interested in. I think this CodeCenter has date stamps and so forth. So the next slide. Well, I kind of mentioned this before, but besides the names of data being different between tools, sometimes it's in a slightly different format. So I mentioned the file path capitalization. Another one is there's a URL which allows you to link back into the analysis tools proprietary interface, but with CodeCenter, the path is relative, just a relative directory, and with Clockwork, you get the entire URL. So in the transformation, I was able to tack on the beginning part of the URL for CodeCenter data. So, okay. So the solution that I came up with, and there are other ways to do the same thing. I've seen sets of instructions folks have written about just sort of cutting and pasting and then renaming columns and shuffling the order and so forth, which actually the order is another difference between the tools. The output data from each analysis tool isn't necessarily in the same order. So the XSLT allows us to rearrange it in whatever order we want also. So it's basically 3 steps. You export the output from your analysis tool into XML, and both of the tools I use, Clockwork and CodeSonar, allow you to do that straight from the tool. We use some other static analysis tools as well, and I'm pretty sure they also give XML format output. Use a XSLT style sheet. So basically a style sheet is sort of a technology that's sort of built right alongside XML that allows you to transform it from one format into another. And a common use for it is pulling information out of databases and turning it into HTML to show on web pages. And then the final step is to just pull the file into a spreadsheet. Okay. So here are some definitions for XML and XSLT. And like I mentioned before, they're both kind of open technology used in internet commerce and so forth. If you look at eBay or online banking or something, it's basically pulling your information out of a database and turning it into a web page on the spot. And this is essentially how it does that. All right. So there are some advantages of using this. One is Excel recognizes XML and XSLT right out of the box, so you don't have to run any special tools on your output. You just basically export the output from the tool. The only really step you have to do is put a reference in the XML file to point to the style sheet, and then you open it in Excel and everything is in the order that you want. So XSLT is designed specifically to transform XML data from format to format. It's easy to configure and arrange the data. So kind of the mechanism that XSLT uses is if you see some pattern, change it to some other pattern. So the order of the document doesn't really matter. So that kind of allows you to automatically reorder information as you go without having to specify what order the source is in. You can also add additional fields in case you want to kind of keep notes about a finding, whether it's a duplicate, whether it's a false positive, whether it's out of scope, etc. So on my example, I added a few fields that I use just for kind of record keeping. And the formatting isn't project specific, but tool specific. And what that means is once you have a template for Clockwork, it works with any Clockwork data. It doesn't, the source code doesn't matter. So, and in the examples here, I ran the exact same template with the open source NASA code that I used with my SLS flight software code when I did my analysis activity. Okay, so let me find my notes here. They're on here somewhere. Okay, so at this point, I go through kind of specific steps for doing the export. Actually, I'd like to go back to my spreadsheet again. Can I just do this? Okay, it worked. Okay, so to give an example of what I'm talking about, what you're seeing here is some raw data generated by this one's code sonar and just imported directly into Excel. Now this URL isn't displaying probably because the field isn't wide enough, but it doesn't really matter. But you see the fields basically are just whatever order the data was in the XML source file. And you kind of have to scroll way over to see what the problem even is. So this class field is basically a description of the checker finding. The categories field is a description of what checker found the problem. Then you have source file, the path name of the file, etc. Don't worry, there's no quiz on this, so don't have to really get it. And then this is the exact same source code ran through Clockwork. And in this case, you see the file path is only the third field. The method, which code center called procedure, is after the path instead of before it. The checker name comes after that. So basically, if you wanted to combine these into a single spreadsheet, you would have to do some rearranging and renaming. And so what I basically did is used an XSLT style sheet to take data in this format and turn it into a different format. And so this is what the output looks like after you run it through the style sheet. So I added a column saying what tool the checker came from. The second column is an ID specific to the analysis tools. And they don't really match between Clockwork and Code Sonar, but it's useful in case you want to go back to the proprietary user interface and find this particular checker to find out more information about it. And so then you have file names, the routine, the line number, checker, a description of the checker, and then as you scroll over, the fields in bold are fields that I just added in order to keep track of doing analysis on these. And so just as an example of how useful this is these first two rows. You can see that they're actually from the same source file. They're from the same method. They're from the same line. But they're one's from Clockwork, one's from Code Sonar. And so the checker has to do with something being unused. The other one, this uval, means unused. And then the description is basically saying there's a variable in this code that isn't being used. And if you're doing analysis on this, you would basically want to go look at the source code to verify, but essentially, I could almost guarantee you each tool found the same problem. So you don't want to open two issues just because two tools found the problem. So you basically mark one of them as a duplicate and use the other one. And it's just readily apparent when you have the data in this format versus comparing this and this. Okay, so back to the presentation. Here we go. How are we on time? I guess we have a few minutes. So the next few slides are just kind of specific directions on how to generate the output. So I'll just go through them real quick. Basically, you export the data from your static analysis tool in XML format. You add a reference to the style sheet in that output file, and it's just one line. You basically copy and paste a line into the XML file, and then you open the XML file in Excel and follow a couple prompts, and Excel automatically reformats the data. So for Clockwork, there are some directions that SWAT provides. And it's essentially you log on to a Solaris server and run some command lines, and you get an XML file, and then you copy that file to your local machine. For Code Sonar, you do it from the web GUI that the vendor provides. So you open the GUI and select the project, and I have a screenshot here. Essentially, this squiggly line here, by default, it displays a certain amount of data, and for our analysis, the categories field is actually the static analysis checker that finds the problem. So since it's not shown by default, there's a way to add it. So you basically right-click on this bar, go down to more columns and select categories, and then it's in your output. And then after that, basically there's a button on that same web page to XML, to export an XML. And so the even squigglier line up here is that button. So you basically just click on the XML button, and then it prompts you to save a file. So once you've done that, you open each XML file in a text editor and copy this one line, which refers to the transform spreadsheet, which I have written, and you just basically put this transformation file into style sheet, not spreadsheet, into the same directory as the tool output. After that, you just open the file in Excel. And so there's a few prompts that you go through. Basically, you get a prompt saying the file contains a spreadsheet. What would you like to do? And it gives you the option to use the spreadsheet referred to in the file versus just let Excel try to import the data however it wants to. So you want to select the transformation style sheet. Then it sort of creates an intermediate file, which is the transformed output from your original XML file, and it gives you this prompt about the file name being different. You don't have to worry about that. You just select yes. And then finally, it asks you how you want to display it, and the default is as an XML table. And that's basically all you do. The last little thing to mention are some notes specific to Clockwork, one of the tools that we use. The latest version of Clockwork doesn't export line numbers by default, so our software tools team has a method of getting the line numbers. So there's a link here giving you directions on how to do that. And then this second one doesn't really